Welcome to this explainer. Today, we're going to dive deep into the invisible battle that's happening right now, in the air all around us, literally, right between the device you're watching this on and the internet. We rely on wireless connections for almost everything we do today. I mean, think about it. When was the last time you actually plugged an Ethernet cable into your phone or your laptop? But have you ever stopped to think about how your private data, your passwords, your messages are actually protected as they travel through thin air? Today, we are going to unpack the fascinating history, the hidden vulnerabilities, and the really complex engineering behind wireless network security. Whether you're a computer science student trying to master the exact mechanics of data protection for an exam, or you're just curious about how your Wi-Fi actually works, you're going to want to stick around for this.
To start getting our heads around this, I want you to think of transmitting data over a wireless network, kind of like shouting a message across a crowded room. Anyone can hear it if they're just sitting there listening. By definition, a wireless network communicates using radio signal frequencies instead of physical cables. Now, this is incredibly convenient, right? It gives us the mobility we love. You can sit on your couch, go to a coffee shop, or walk around your office without losing connection. But, and this is a massive but, it completely changes the rules of the game when it comes to keeping our private data secure. Because we've removed the physical boundaries, we've also removed the physical security.
So here's our roadmap for this session. We'll start with the wireless revolution, then look at the invisible threats in the air. After that, we'll break down passive versus active attacks, look at WEP, which was our first line of defense, and see exactly how hackers broke WEP's armor. Finally, we'll cover WPA and how modern security actually keeps us safe today. Let's get right into it.
Section 1. The Wireless Revolution.
Okay, let's look at the basic anatomy of a wireless setup. It primarily relies on a central router or an access point that's constantly broadcasting radio waves. These waves are picked up by network interface cards, or NICs, that are installed in your laptops, smartphones, and tablets. Whenever your computer sends out an email or loads a web page, that binary information, all those ones and zeros, is encoded into a radio frequency. It's then transmitted through the physical air to the router, which grabs it and decodes it back into binary data to send out to the internet. It is an absolutely seamless process that happens in milliseconds, giving us that incredible flexibility we're all used to.
Section 2. Invisible threats in the air.
Now, what is really interesting, and honestly a bit terrifying, about this convenience is the massive inherent vulnerability it creates. Because these signals have no physical boundaries, anyone with a receiver in the parking lot outside your office or in the apartment next door can simply capture your data right out of thin air. Think about a traditional wired network for a second. To hack it, an attacker literally has to walk into your building, find an Ethernet port, and physically plug a cable into the wall. You can lock doors to stop that. But with wireless technology, those radio waves easily pass right through walls, windows, and doors. This extended range means an adversary doesn't even need to set foot inside your building to eavesdrop on your most sensitive information.
Section 3. Passive versus active attacks.
In the world of network security, to figure out how to defend ourselves, we first have to broadly categorize these airwave threats. This taxonomy gives us a really clear picture of exactly what we are defending against. Let's break down the two main buckets.
The absolutely crucial point here is understanding the fundamental difference between passive attackers and active attackers. Passive attackers are the ones who just quietly sit there and listen. They don't alter any data. In a passive attack, the hacker is simply gathering intelligence. They use tools called packet analyzers or packet sniffers to read your unencrypted data or analyze your traffic patterns, like who you're talking to and how much data you're sending, without you ever knowing they're there. It's like someone secretly recording your conversation. But in an active attack, they go on the offensive. This is where data gets altered or disrupted. They might masquerade as an authorized user to get into your system, they might intercept your legitimate messages and alter them, or they might launch a denial of service attack, blasting the network with so much garbage traffic that it completely shuts down.
Section 4. WEP, the first defense. So how do we stop these attacks? Early on, engineers introduced WEP, which stands for Wired Equivalent Privacy. The goal was right there in the name: make wireless just as private as a wired connection. WEP acts as a secret language, using 3 specific cryptographic steps to scramble your data so that any eavesdropper just hears useless static. Step 1, it generates an initialization vector, or IV, and combines that with a secret key that you and the router both know. Step 2, this combination is fed into a mathematical algorithm called the RC4 cipher. This creates a long, pseudo-random string of characters, basically a stream of gibberish.
Step 3, it uses a logical mathematical operation known as XOR to blend your actual plain text data with this pseudo-random gibberish. The result is a securely encrypted data packet that gets blasted out into the air.
Let's look at this diagram to really visualize the flow. During transmission, the access point and your device both use that shared secret key to lock and unlock the payload. When your encrypted data reaches its destination, the receiving router reads that initialization vector, grabs the shared secret key, and essentially runs the exact same RC4 process in reverse. Because both devices share the exact same key, the second XOR operation perfectly cancels out the first one, stripping away the gibberish and revealing your original data. At the time, it was an incredibly elegant system designed to keep the bad guys totally locked out.
Section 5. Breaking WEP's armor.
But, as you probably guessed, in the world of cybersecurity, the mouse quickly learns to outsmart the cat. You might be wondering, if WEP was using complex math and secret keys, how did it fail so spectacularly? Because today, WEP is considered completely broken. Well, the problem wasn't necessarily the math itself, but how the system was actually implemented. Researchers eventually discovered a fatal flaw in how WEP handled those initialization vectors we just talked about.
Here is where it all fell apart. It turns out, WEP generated incredibly weak keys. The initialization vector was only 24 bits long. That might sound like a lot, but in computer terms, it means there's a relatively small pool of unique combinations. On a busy network, you'll cycle through all those combinations in just a few hours. When that happens, the system is forced to reuse keys. Hackers realized that by passively monitoring the network and collecting about 5 to 10 million data packets, highly predictable statistical patterns would emerge. Once they captured enough of these reused keys, readily available software, like a program called AirSnort, could crack the entire network's secret key in less than a second. It literally tore the doors off the whole system.
Section 6. WPA and modern security.
With WEP fundamentally broken, the industry had to rapidly evolve to build a much stronger defense system. Let's look at how Wi-Fi Protected Access, or WPA, builds a significantly better wall. The biggest game changer was moving away from WEP's static shared key to something called TKIP, the Temporal Key Integrity Protocol. This means instead of using one key over and over, WPA generates a unique temporary key for every single data packet. Imagine changing the locks on your house every single time someone walks through the door. On top of that, they doubled the length of the initialization vector from 24 bits to 48 bits, practically eliminating the key reuse problem. Finally, WPA replaced WEP's super weak data integrity checks with a highly secure cryptographic hashing function, making it mathematically exhausting for an active attacker to tamper with the data without getting caught.
So how do we actually apply this to your own life and your own devices? Here is a structured list of best practices that will add essential, multi-layered security to both your personal and corporate networks. First and foremost, never, ever use the outdated WEP protocol. Always ensure your router is set to WPA2 or ideally the newer WPA3 standard. Next, make sure you change those default administrative passwords on your router immediately. Hackers literally have lists of default factory passwords. They know what they are right out of the box. Furthermore, if you are working remotely or just browsing at a public coffee shop hotspot, always use a virtual private network, a VPN. Combine that with secure TLS and SSL connections, and you've basically built an impenetrable encrypted tunnel for your data straight through those public airwaves.
I want to leave you with this final thought to consider. Think about the network you are connected to right now. Is it truly secure? Or is someone sitting just out of sight, listening to the invisible airwaves? The space around us is constantly buzzing with data. And while modern encryption protocols like WPA3 are incredibly strong, the battle between cybersecurity professionals and malicious hackers is an ongoing, ever-evolving game of cat and mouse. You have to stay vigilant, keep your devices updated, and never ever take the security of those invisible airwaves for granted. Thanks for watching.